Okay, now members, we are going to see multiple questions about angles of elevation and angles of depression. But please don't forget to subscribe to the channel. So, we are going to go through this one. So, they are telling us that the angles ladders made with the top of the building 12 meters high with their feet at points A and B are 55 degrees and 65 degrees respectively. Find the distance between points A and B. Now look at this. They're telling us that this point A is going to make an angle with the top of this building 55. I mean, if this is 55, it means that the one which will make 65 is going to be at a longer distance from the wall than this one which is making 55. That's why mine here, which is 55, is at a shorter distance from this than this one which is at 65. That's the idea. Or is the angle from this wall, the one which is having a bigger angle from this wall is going to be at a very slanting than this one, which is having a smaller angle. So that's why A is 55 from here, then B is 65 from this wall to the ladder. That's like that. So you need to get this distance, AB, the distance between the feet of those two ladders. Now what I'm going to do is to get this DA first, then I get DB, the whole distance. When I get this minus this distance, DB minus DA, I'll be able to get this. Why am I using that? Because I'm seeing that these are right angled triangles. So this triangle with DA is right angled, and also this triangle with BB is right angled, and you can only use those ones in the tree of the sine, cos using the opposite and the adjacent. Now, from there, now I'm going to use the triangle ABT. Using ABT, that this angle now here is 55. This is my B, this is my A. I want to get the A. Now then I am going to use, because you get this, you have the angle and you have the adjacent. So we look at our time using SOHCAHTOA. Our SOHCAHTOA says that always our time is opposite over adjacent. So we have the angle, we need the opposite, we have the adjacent. So our opposite to this angle is going to be this, since opposite this, which is BA, over the adjacent, which is 12. When you cross multiply, our angle is tan 55, cross multiply, then this will be to do the small presses that. Then now, I need also to get this big length. So why? Because this triangle with the big length is right angled. So if I pick it out there, remember, from here up here is 12 meters. So now, if I use tan 65 equaling to BB over 12, it's going to be now, because this is my opposite, I have the adjacent and I have the angle. So I need now to make BB. If you cross multiply that our BB is going to be tan 65, then which simplifies to this. So now we know that how are we, after getting our BB, we know that DA plus AB will be giving us BB. So meaning that my DA, I have it already, and BB, I have it already. So if I take this side, I'll be just subtracting this AB. Okay, this is AB and the same as BA. Then my 25 BB minus BB minus BA, which is 17.1, will be giving me AB. And that's when you subtract, that's what you get there. Now, let us come to this one. From the roof of the house, 17 meters high, a boy can see a tree 20 meters away from the house. His angle of elevation to the top of the tree is 31. Now, this is the house, but remember that this house is 17 meters high. Now, if this house is 17 meters high, what are we going to consider there? Now, to consider from here to here is 17 meters high. But remember, this boy is also having a certain height, x, from here to here. So this is the top of the house, but this point is at the roof. Now, is having this angle of elevation to the top of this tree. I'm assuming from here up here is my tree. So this angle is 21. Then this one to the bottom of the tree or to the foot of the tree is 43 degrees. Now, I want us to get the height of the tree. Everything here in this angle of elevation, depression, works with the right angled triangle. Now, when I look at this, If I hold from here up to here to be my H1, from here up to here, then from here up to here to be my H2, because this is the right angle triangle and this from here to the right angle triangle. So you start to get the height of the tree, I will sum this height and also this, it will give me the sum of the whole tree, the height of the whole tree. Now, so here, if I use this triangle up there to get this H1 first, using opposite, you have the adjacent, you have the angle. That's what you get, H1. Then H2, now if I use this triangle here, I have this, I need this, I have this. Now, this 20, the distance from here up to here is the same as distance from here up to here. That's why I said this one is 20 meters. From here up to here is the same as from here up to here. Then also the same case, if I use this triangle here, from here up to here will be the same as from here up to here, also 20 meters. And doing that, that's what we get there. So doing this and then our H2, when we add these two, we get that there. Now, the other idea is, now, after getting the height of the tree, from here up to here is 26.3 meters. Now, they're asking us that B, the height of the boy. So now our boy, so this height from here up to here is the same as the height of this building plus the height of this boy X. So that X plus 17 will be giving us the whole of that H2. And if you do that algebra, your boy is going to be 1.65 meters. And so that's how we handle that number. I wish you well.